So imagine you have a coil. Okay, so a coil connected to a battery and you have a key. Now, so what you guys studied till now is you press the key, the circuit is complete, current flows through the coil. As the current is flowing through the coil, meaning the current is increasing and increasing, current is rising, the magnetic field linking with the coil will also change, correct? The magnetic field also increases and increases. Now this is one thing what you guys know. Now, one more thing you guys learned was whenever there is change in magnetic field linking with the coil, EMF is induced, correct? But look at the situation. In this case, you have a coil. From the coil only, you have increasing magnetic field. And that increasing magnetic field is linking with the same coil, correct? That means there has to be some induced EMF within the coil, correct? So what we have here is what we call as self-induction. Okay, self-induction meaning you have a coil. Okay, the magnetic field from the coil is increasing because of the current from the battery. Alright, so as the magnetic field keeps on increasing, that change in magnetic field will come and link with the same coil. So that will induce the EMF in the opposite direction. Okay, so in the sense what you have, see, I'll just break down the circuit step by step. Alright, and then we'll combine. See, the first circuit is from the battery, the EMF, the current is going, and then magnetic field keeps on increasing. Okay. Now what we have in the second circuit, so the magnetic field from the coil, that is actually coming in linking with the same coil, correct? It's coming in the same coil. So the EMF induced will be in the opposite direction, correct? Now see, merge these two together. So this is what you get. Meaning we have something known as self-induction. Okay. So suppose let's say 3 volts is going to the coil. Because of self-induction, what happens? An induced EMF in the opposite direction will come. So it won't be 3 volts in the complete circuit. If you actually calculate, it will be lesser than 3 volts. Okay, whatever it might be, it will be less than 3 volts. So this self-induction of a coil plays a very important part. As you can see in the next chapter, you will see why this is important. Okay, so now before we go to the next video, I have a simple question. Suppose let's say you have a straight wire. What is the self-induction of a straight wire? Okay, the answer will be there in the next video.